In the last video, we have simulated the atmospheric distillation column. In this video, we will treat the atmospheric bottom in the vacuum tower. So for this section, first we have a mixture, then heater, and the separator section, there is a unit operation named with vacuum residue tower. There is steam that will mix with the atmospheric bottom. It has the temperature of 126.7. The heater will heat the steam. Up to the temperature of 404.4 and pressure will be 0.24 bar. In the tower, it has already defined some streams that will be linked with the external streams. You may use them or you can add the stream by yourself. Currently it has 12 number of stages. In my specification I need to add 2 more stages. And my main stream, that will be the feed of the tower, it will enter at the 12th stage. Another stream I will define it as vacuum steam, and it will enter at the bottom. Other than these two, I don't have any stream for the feed. In the product stream, the vacuum overhead, which will be fuel gas, bottom is vacuum bottom, then light vacuum gas oil and high vacuum gas oil. Delete the unnecessary streams. In the side operation, you can see 3 pump rounds, although I will use the 2 pump rounds, light vacuum and heavy vacuum. The light vacuum has a draw stage of 4 and return is 1, and heavy vacuum draw stage is 8. Return will be 5. The bottom pressure is 0.0826 while top is 0.066. Now in the monitor section, you need to define 6 parameters to make the degree of freedom 0. So first I have a light vacuum gas oil draw rate, heavy vacuum draw rate, heavy vacuum pump around differential temperature, heavy vacuum pump around rate, it have an at the light vacuum gas oil pump around rate. I will add the specification, pump around, flow rate, pump around is light vacuum gas oil, volumetric flow rate, and it has the spec value of 147.7. I have defined 5 parameters. Now I will define the bottom temperature to make the degree of freedom 0. Before running the simulation, we need to define the vacuum stream, which has the temperature of 260, pressure of 11.36, and flow of 9072. Now we can run the simulation. So it's not converging. So let's hope we can define some estimation in the profile. Let's have a top temperature of 83 and second stage is 165 will be enough. Oh, it's converged. So in this way you can define the estimations over here to make the flow sheet converge faster. Now as we have done in the atmospheric column, we will add the cut points. First cut point for the light vacuum gas oil and its draw point is stage 4. This time we will use the type of D1160 ATM and we have a cut point 95% and the spec value is 501.7. And for the heavy vacuum, The draw stage is 8. Now let's come a bit closer. So I will deactivate the light vacuum gas rate and activate its specification, cut point specification, and similar goes for high vacuum. So our tower has been converged. Now so far we have simulated the atmospheric tower and the vacuum residue tower. In the next video, we will treat the naphtha from the atmospheric tower in the catalytic reformer, and the bottom residue of the vacuum will be treated in the wisp breaker.